Welcome to Lesson 5.4, Part B, Point-Slope Form. Today our goal is to be able to graph an equation in point-slope form. Yesterday's lesson was how do you write an equation in this form. Today we will be graphing. Remember, with point-slope form, we're given two pieces of information, the slope and a point along the line. Those are the two things we're going to use to graph the line. Think about, how would you graph a line if you only knew the slope and a point that the line went through? Well, we're going to find out. Taking a look at example number 1, I give you only a point and a slope. With this information, graph the line. Let's give it a try. Well, how do you think we're going to do this? When we graphed equations that were written in y equals mx plus b form, we also started with a point. We started with the point of the y-intercept. And with that point, we were then able to graph it by using additional points from the slope. So the same type of concept we're going to use when we do this. We know that the line goes through the point 3, -1. So we have to have a starting point. Let's start by graphing that point. To the right 3, down 1. I'm going to make a point right there. Now, this line could go any which way. It could go this way, it could go that way, it could go vertical, it could go horizontal, any which way. Well, what else do we know about this line that goes through this point? It has to have a slope of 1/4. So that means we need to have a rise of 1 and a run of 4. So I'm just going to make this a little bit bigger so you can see it. All right, so there's my slope, 1/4. So if I start at this point, I can just rise up 1 and run 4 to the right and make an additional point. I could even fall 1 and run 4 back to the left and make an additional point. I just connect the points and I have the line that goes through the point 3, -1, and has a nice slope of 1/4, up 1/4, up 1/4, up 1/4. There we go. Okay, so very similar to graphing this way. You start with the y-intercept point, and then you make additional points using the slope. Here we start with the point given, and then make additional points using the slope. Not too bad. Okay, but in number 2, we're just given the equation. Y minus 4 equals 2/3 x minus 5. The equation is in point-slope form. So we need to be able to pull out the point and pull out the slope. So that's why we were kind of practicing this in the last lesson. Well, slope's easy, 2/3. The point is where it can get a little bit trickier. So remember, this is x minus the x coordinate, that's 5, and y minus the y coordinate, which is 4. Okay, so now let's go to graph it. Again, we're going to begin with the point. So location is at 5, 4. 1, 2, 3, 4. There we go, 5, 4. So the line has to go through that point. But what else do we know? It must have a slope of 2/3. So from this point, I'm going to rise up 2 and run 3 to the right. I just need 2 points to make a line. I could also fall 2 and run 3 to the left. Connect the points, and I have a straight line. Okay, two things are true. It goes through the point 5, 4 here, and it also has a slope of up 2/3, up 2/3. Ta-da! There it is. Let's try number 3. Here's the equation to write down. Okay, what do we know? We need a point and a slope. So slope is -2, and the point, well, x minus the x coordinate, that's 2. This came from y minus -3. So that's why it became plus. So the y coordinate's actually a -3. Be careful with that. We have to get the correct point for this to work. Okay, so again, when we're graphing, we need a starting point. So let's graph this point. To the right 2 on the x-axis and down 3. There we have a point. Okay, line has to go through there. We're going to make some additional points using the slope. So slope is -2 or -2/1. So now I have a rise and a run. I'm going to rise up 2 and run 1 to the left because this is a negative slope. So again, rise up to 1 to the left, up to 1 to the left, okay? When I connect those points, I'm going to have a nice negative, a falling line of a slope of -2. And there we go. Now, with number 3, I could take that equation right here, and I just rewrote it here, and I rewrote it into slope-intercept form. So I just distributed, added the subtracted the 3, and this is what I get. Do you see how the slope of -2 is the same? But do you see how here in this form I can see the intercept's +1? Well, let's check out the graph. The intercept is +1. And you see on the graph, the intercept is at +1. So what I could have done was I could take this equation, rewrite it y equals mx plus b, and then I could graph it in this form. I could start with the y-intercept and then make additional points using the slope. These two are equivalent. All right, here's 4. So copy y plus 5 equals negative, and then in parentheses x plus 2. So what is our slope? Negative, that's a 1, -1. Remember, this would be -1/1 when we're talking rise and run. Now for the point, x plus 2. Well, this came from x minus -2 to make it a plus. So the x coordinate was -2. This came from y minus -5 to make it into a plus. Right? So this is -5. Those can be tricky. All right, we have to have a starting point. So it looks like our starting point, xy, is going to be -2, -5. So back to -2 on the x-axis. Up. Oh gosh, you guys, forget that. What did I do wrong here? This is supposed to be negative. So back to 1, 2, 3, 4, 5. There it is. Delete that. We'll just kind of make a line through it. There we go. It never happened. Okay. So there we go, -2, -5. And then we need additional points using the slope. So we can rise 1, run 1, up 1, left 1. It's negative, up 1, left 1, up 1, left 1. I'm going to go backward, down 1, right 1, down 1, right 1, down 1, right 1. And then I'm going to connect the points. Now, I graphed this using point slope form. I took out the point, I took out the slope, and I graphed it. But if I took the same equation right here, and I just solved it. I rewrote it, solved it for y. I distributed, I subtracted the 5. Do you see that? And let's say I wrote it in y equals mx plus b form. Do you see how the slope is the same? -1, -1. But do you see how now the y-intercept, I can see the y-intercept is -7. Right? Well, look at the graph. There's your y-intercept at -7. See, these two are the same line. They look different. They're just in different forms. Okay, but I could have rewrote the equation slope-intercept form and then graphed it that way with the intercept here and then up 1, left 1, up 1, left 1. I could have done the same thing. Okay, then let's look at number 5. Okay, last one like this, and then we're going to talk about why you need to learn how to do this. Okay, so go ahead and copy y minus 6 equals -5 halves, and then in parentheses x plus 1. Okay, so slope, that's easy. That's easy to see. That's just -5 halves. And then the point, this comes from x minus -1, so that's -1. And the y coordinate, y minus 6 is just 6. Okay, so let's graph it. Point, -1 on the x and up 6. 2, 3, 4, 5, 6, right there. Okay, and then the slope is -5 halves, so it's negative. Rise is 5, run is 2. So if I rise 1, 2, 3, 4, 5, I'm off the graph. Can't do that on a computer if you're off the graph. It's not going to allow you to make a point. Okay, we need to be able to do this on a computer as well. So I'm going to have to fall 5. 1, 2, 3, 4, 5. I fall 5, and instead of running to the left toward the negative numbers, I run 2 to the right. So 1, 2, 3, 4, 5. I fall 2 to the right. And then I can connect the line on a computer. A lot of times, like it'll connect it for you, like on the MCA or on IXL. Okay, so here I can see that we've got the point, -1, 6, and then I also have a slope of -5 halves. 5 rise, 2 run, 5 rise, 2 run, and it's falling. The line is falling. It's negative. So that's all you do, really. You just first start with your point and then just make additional points using your slope. So you may be wondering, and this is a great question if you're wondering this, I hope you're wondering this, why do we need to know how to do this? Why would I need to know how to graph in point slope form? Why do I need to know how to do that? When Mrs. Johnson clearly taught us how to just rewrite this y equals mx plus b, why do I need to learn how to graph in a different form? And generally, I would ask you this question and we would discuss it. But let me just show you this example here. What if you were given this equation and your plan was not to learn how to graph in point slope form? Your plan was like, you know what? I am just going to rewrite this y equals mx plus b every single time. So let's say that was your plan. So let's do that. Let's rewrite this. We're just going to distribute here, and then we're going to minus the 3, and you get this. Well, not such a good plan. What's going to be the problem here? If this is the coordinate plane I'm given, and if I have to graph this line, you see the problem? A negative 38 slope. There's no way that I can plot a point down at negative 38. It's not even on the graph. So in this case, I would definitely want to be able to graph with point slope form. So let's just quickly do that. If I did it in point slope form, my x coordinate is 5, my y coordinate's negative 3. So I go 1, 2, 3, 4, 5, 1, 2, 3. I put the point there. I'd make one additional point using the slope, 1, 2, 3, 4, 5, 6, 7, and I'd go to the right one because it's positive, and then I could connect the line. Bada boom, bada bang, right? Now imagine this line is going to continue going down, 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 and it's going to hit the y-intercept down here at negative 38. But I can graph it with 2 points. So if I'm using a computer, point here, it will draw the line for me, okay? So that's one of the reasons. Sometimes you just can't rewrite it in this form because the intercept's off the graph. Okay, let's think of another reason why we couldn't just always rely on changing it to y equals mx plus b. Well, here's a great example. You might be wondering, well, what's wrong with this? Well, look what happens. If I take this equation right here and I start distributing, ooh, that's icky, and then I add the 5 to both sides, that's super icky. Look at this y-intercept, 3 2/3. Are you going to be on a computer? Are you going to be able to go up exactly 3 2/3 and make a perfect point on 3 2/3? No. So what if the intercept is an icky number that's not a whole number? Then you're going to have a problem. So again, that's why we learn how to do this in another form. Let me keep it in this form. The x coordinate's negative 4, the y coordinate's 5, and then I go 1, 2, 3, 4 on the x-axis, 1, 2, 3, 4, 5 on the y. I graph another point using the slope, up 1, left 3, and boom, I'd have the line. Computer would graph it for me. Now, if I continued this line, yeah, it's going to go through the intercept of 3 2/3, but I can graph it now. All I need is 2 points and I have a line. So yeah, we sometimes can write equations. Oops, there's my example. We sometimes can rewrite the equation in slope-intercept form and graph it, but we can't always do that. If our intercept is really icky, or like it's off the graph, if it's off the graph, or if it's not a whole number, we're going to run into some problems. So that's why we have to learn how to do graphing in other forms. Okay, so here's our summary. To graph an equation in point slope form, this is what I want you to focus on. If it's already in point slope form, first graph the point from the equation and then use the slope to plot additional points along the line. Well, if you get an equation in this form, you could also rewrite the equation in slope-intercept form and then graph it. However, this does not always work, okay? So that's why it's important for us to learn how to graph in point slope form. Thank you so much for joining me for the video. I hope that it was helpful and you feel like you know how to graph equations when they're in this form. Have a great day.